Hi, this is Harish here. Welcome to DB2 LUW Performance Mythbuster part video tutorial part 3. The tip in this I wanted to provide you is there is a attribute of the table activate not logged initially. It will behave as only a space saver rather than a performance booster. Usually there is a claim that if we set this activate not logged initially attribute and you run some update query or delete query for deleting a huge number of records, the claim is that that query is going to run faster, improving the performance, rather than if you have a logged query and it is deleting it, right? So that is not the case. So that is what I am going to prove here, and I have some examples also as usual. Please subscribe to my YouTube channel, youtube.com/db2luw academy. And so this is a problem scenario. So the first thing that I wanted to mention is there is no general solution for performance. It needs to be dealt on a case by case basis. So don't take this as like a word test for yourself, and it will vary on case by case basis. There is no general solution for performance. Okay. Now why I am claiming this? There is an activate not logged initially attribute that we set on a table, and after that we usually run some huge delete queries or some update query, and it will not generate a lot of transaction log files because of that, and which is the space saver attribute. Okay, so that is only for space saving nature. Okay, so and generally we extrapolate that claim to it will improve performance because it is the logging overhead is removed completely, so the query will run faster. But that is too far a claim. Like it is not helping in improving performance as we expect. Okay, so that is what I wanted to show, at least in case by case basis. So there is a case wherein when certain conditions are met, that claim is not true. It's not generally true. Okay, so the claim that improving performance, like the not logging of transaction will improve the performance, is a very general statement. It is not true in all cases. So why I am saying that is, you are limited by your data bar index, hard disk IO speed, or bandwidth. So and another important factor that you should consider is transaction logging disk IO speed. So there is like you have the table is in a table space, the table space ultimately is in a container, the container is going to be a file, the file is going to be in a hard disk. So the hard disk IO speed, and you see like in certain environments the data index, the multiple table spaces will be there, multiple tables will be there. So each of the tables, like one table space will house 20-25 tables like that. It's not like each table is in each table space kind of a environment. Not always. Certain environments will be like that, certain environments may not be like that. So wherein the disk IO speed is getting shared between multiple tables. So if you are accessing some table, some heavily used table, and you are running the activate not logged initially on another table, right? So which means like when you request for that, the hard disk speed is already consumed by the fast accessing table, so you will get some limited speed here. Like those kind of things can happen. So, and another important thing is the transaction logging disk IO speed. If your transaction logging disk IO speed is very superior than your data or index hard disk speed, then definitely it will not improve in performance. Like for example, if the transaction logging disk IO speed is very high, you get like full speed logging disk, whereas you have limited data index hard disk IO speed. In that case, the activate not logged initially will not improve much performance the way we expect. Okay. Why? The reason is, when you activate not logged initially and run the update query or delete query, there is a lot of synchronous writes happening rather than direct writes. So this will, like if you use load utility, it will do something called as direct writes, which means it is bypassing the buffer pool and it is directly writing into the disk. Okay, whereas in activate not logged initially, even if you run an update query or a delete query, it will run for a long time because it has to read it from the disk, put it in the buffer pool, update it in the buffer pool, and the buffer pool will get filled, and the page cleaning and other things has to happen. And you are going to see a lot of synchronous writes happening in that case. And what we understand about synchronous writes is always a costlier operation it's costlier operation than the asynchronous writes. So if we find a query is getting executed and there is a lot of asynchronous writes, then we say the query is, the buffer pool and the query is in an optimum working mode. Whereas if you see a lot of synchronous writes, then the agent which is executing the query itself has to perform the buffer pool to disk IO, which means which is not a good situation to have. So if you are going to see that, then activate not logged initially will not improve your performance, rather it will only save you some space in terms of transactional logging. And if you have a high disk IO speed transactional logging, and usually transactional logging disk IO speed is usually a very high speed device rather than the data disk or the index disk. Because in the data or index disk might not be accessed very frequently, so you can live with slow speeds there. Whereas transaction logging, see, if there are 50 concurrent users, so many transactions or update transactions or running delete transactions, then you need a high speed disk any case there. Sorry, which you cannot avoid. So it becomes a very general solution. Like when somebody, I would even call it as an extrapolation. So I will give you with example. Okay. Let's take an example here. Okay. So let us first show you the script. Okay. So I have started how it starts is actually I'm dropping the table staff. There is a separate table space for data, separate table space for index, and I'm creating a table staff with ID, name, and whatever the column. The data is in a separate table space, index is in a separate table space, and I create an index on ID, name, and salary. It's not even a unique index, and I perform the run stats, and I load the data 1 GB primary key dot del. So it has like unique values, even though I'm not creating a unique index. Still the data is 1 GB and unique numbers will be there for the ID column. Okay. So and I have inserted all these steps are already done. Okay. And after that, what I'm going to do is there are two scenarios. So I'm going to show you the first scenario. I'm going to start, activate the database, connect to the sample, and I'm going to run this query. Okay. So this is like I'm directly running. So there is no I'm not activating not logged initially. Okay. So because you can see that this is the test case where I alter the not logged initially and then I run the update command, but I'm not doing that case. So this case is like I'm just directly updating the staff table without activating any not logged initially, like those attributes. I did not set any of those things. So I'm just going to run the query. Okay, let me go to the system. So you can see I have done the DB2 start and all that connection and everything. So let's quickly do that. And before that I have to, nothing. So we'll just run this query. And I have already here performed the reset monitor all, and you can see here, see the BP data and BP index is running. So okay, let's look at this one. So nothing is happening yet. Okay, let's check. Yeah, it's still running. Let's check. There is still no asynchronous writes. So at least we should get some buffer pool. So there is BP data. There is a separate buffer pool for data and separate buffer pool for index. And you should see the buffer pool data writes and asynchronous data page writes. Okay, so this is the first time I'm running, right? So after activation, so maybe this is going to be a little bit slower than usually we expect in the sense. Okay, so let's see. Okay, did I switch I think I have the monitor switch on, so let's check that. I think I set it. Yeah, reset monitor, buffer pool on, everything is set. Okay, but I don't know why it's not showing. It will take about 5 minutes, so let's see. That's weird. Okay. Am I connected to the correct database? Yep. Okay. Yeah, so you can see now the temporary data logical reads have come up. So it is doing something, and the first run is going to take about 5 minutes, so that is for sure. Okay, that is definitely there. The first run is going to be extremely slow, and I think it's going to take about 5 minutes or so. So the first run, the second run and third run, we can expect some reduction in time. So let's see that. Okay, and I will also show you the IO stat -d space 2. Okay, so this will give you an idea of how much. See, you can see the SDC, the index page, the index table space is getting hit at 1024 KB per second, and I have set a limit such that the SDC disk will run at only 1024 disk. Now you can see SDD, the data portion is getting heavily red, and SDB is heavily getting written, and you can see the difference, right? 5206 KB, which is 5 MB, whereas here it is 1 MB. SDB is your logging disk, so so the speeds are different. So what I'm saying is SDD is your data disk, it will not exceed more than 1 MB. SDC is your index disk, that will also not exceed more than 1 MB. And SDB is your logging disk, you can see that it is going up to 5 MB like that. So it's really fast, 5 times faster. Okay, and so we'll see now the so you can see the BP index is running, BP data is running, and the temporary data is also getting created. So maybe when as part of the update operation some temporary table is getting created, and based on that the data and indexes are getting updated. So the first run should be really tough. It should be like really 5 minutes, so we'll have to wait it out. There is no other option. Okay, so we'll see. Okay, because this is the first time it's getting activated, and this is the first time it is getting, the buffer pools are getting filled up with the pages from the hard disk. So the first run we can expect always. So that's why in the test case what I have is, this is the first run, then I'll commit, then there will be a second run, third run, fourth run. Then I should see some gradual decrease in the time it takes. Okay, so that's the idea. Okay, so let's wait it out. And I think this is like extremely slow, you know, rather. Oh, okay, yeah, it completed. So you can see that in 5 minutes it got completed. 5 minutes and 20 seconds it took. So obviously the next command will be to commit the transaction. Okay, so let's go and commit. See and also note that the commit is like really fast. Okay, so 5 minutes and 20 seconds is the first run. Okay, and after the first run what I'll do, nothing. So second query, so this is the second time I'm going to run that. Okay, so this time it should be somewhat faster, and here I will reset monitor all. Okay, so then I'll go for that. Okay, so now this is the index page, right? So we want to see how much of synchronous writes and asynchronous writes are happening. So okay, so now let me paste, and here you can see that I'm not giving the same value. I'm changing the query value so that it becomes a different query. Okay, let's run that. See, now the BP index and BP data are filling up somewhat real faster than the previous time. Okay, 5 and 14. Even this time it will take see, first time it took 5 minutes and 20 seconds. This time it should take about 3 minutes, because I have done this test case so many times. So roughly around 3 to 3.5 minutes it should complete this execution. Oh, it's 31 seconds. That's superb, right? That's a very good improvement. Okay, 31 seconds. So it completed its execution in 31 seconds, which is a good sign for us. So in 31 seconds, everything got completed. So you can see in 31 seconds, everything got completed. I'll again reset monitor all. Okay, so we can see it again from the first. Okay, now I'll run it for the third query. Copy that. Okay, paste it. So this was 31 seconds. Let's see for this next run how much it takes, and we'll look at the index page writes and other things. See, now you see how fast it is writing. 2115 3379. It is writing so much of it. And okay, this is the important point. See, out of this buffer pool index writes, all of them are almost asynchronous, right? Similarly, in default buffer pool also, all of these data writes, all of them are asynchronous. So there is a lot of page cleaning activity, or like asynchronously the buffer pools are getting cleaned. That itself is a very huge positive point for us, and the data is still not changed here. I think it will complete the index and it will come for the data. So let's wait for that. So some 12,691. Yeah, this time it is going to take a little bit longer. So earlier it took 31 seconds because of the caching effect. Maybe for some reason now again it is taking some time, but definitely it will not take 5 minutes. It should take 3 minutes, because that's what I saw. 3 to 3.5 minutes it should take. So let's see that. Okay, and we'll continuously run this. See, as long as I run this, you can see that whatever the index writes are happening, it's all asynchronous. The asynchronous, so these are the two lines. You can see the asynchronous pool index page writes and the total buffer pool index writes are pretty much the same. So there is the agent is not performing any synchronous writes in the index buffer pool. Similarly, in the data buffer pool also, the agents will not perform any synchronous writes. It will be asynchronous. So that is what I want to show you, but it is going to take a little bit time. So this is going to be a lengthy video. So we'll have to wait. The already 5 minutes is over. So this again now another 3 minutes we have to wait. Okay. So in the meantime, let's see how much it is going. So you can see here 32,067, 33,047, and you see a lot of index writing first, and then only the data writing is happening. So there is some kind of order in which it is performing its activities. The update is not like you go and directly update the data first or something like that. I don't know. I'm not very 100% sure on this. But yeah, let's see. Okay, whatever it is, like the point is, if we run this without, see, currently I'm running without activate not logged initially attribute set. Okay, and it is performing asynchronous writes. No agent is performing synchronous writes, because it is in the buffer pool. We can see this buffer pool index writes and asynchronous index writes are the same number. So which means it is not performing any synchronous writes. Okay. So I'm sorry, you will have to wait that 3 minutes. I think this time it is going to take more time, but definitely it will not be 5 minutes, because the buffer pool is already flushed with so many pages, right? Filled with so many pages. So because of that caching effect, we got 31 seconds. But now again, some buffer pool pages are getting cleaned, and again they are getting returned along with archival. So there is also the transaction logging overhead is there. So you can see it come 3.5 minutes. It completed in 3.5 minutes. This is what I was trying to say. And I'll commit the transaction. And you can see, like, if you look at this, see 54 625 asynchronous writes. The same is the buffer pool total writes. And you can see in the data table space also, whatever the request, the total buffer pool data writes were there, everything was done asynchronously, nothing was done synchronously. So this is the important concept. So let's reset monitor all. Okay, and so now I'll have to run the same query again. Okay, so this is the same query. So I'll run this again. Okay, did we do reset monitor all? Okay, I did reset monitor all. So I'm going to run this one more time. So maybe this time again it might take 3 minutes, or maybe because of the caching effect it might run faster also. So I'm not sure about that part. So let's look at that. Yeah, you can see how much of data it is writing, how much of index it is writing, and everything is again still in a asynchronous mode, right? See, out of 5743 writes, everything is in asynchronous mode. It's not writing in a synchronous mode, right? So we'll run here. So 8001. Let's see. Completed. 31 seconds. So it is a very good deal, right? Considering that. Okay. So DB2 connect commit. I'll connect reset. Okay. So this is one test case wherein we are saying, like, there is a lot of synchronous writes. I mean, there is a lot of asynchronous writes happening. There is no synchronous writes happening. And whatever the query is running, the maximum time it took for running was 5 minutes, because that was the first time after activation. So it took 5 minutes. After that, I am able to get 31 seconds. After that, I am able to get 3 minutes. After that, I'm going to get 31 seconds. So the caching effect is there, and it is really good to have, like, between 3 minutes and 30 seconds. If the query runs faster because of the caching effect, it is always a good thing. And if it takes 3 minutes, it's okay. What else we can do? If it's going to take 3 minutes, it's going to take 3 minutes. Okay. So this is the thing. Okay. The point is here, no synchronous writes are happening. So that definitely, because of that, the system will perform better. Even the logging is happening, because I did not set the activate not logged initially attribute. So the logging is happening. So that is a thing. And note that I am not even deactivating the database. So I've just done connect reset, and if you say DB2 list activate databases, so list active databases. Okay, so the database is in still memory. Okay, actually I should deactivate and activate and perform the test, but I'm not going to do that. Okay, so let's see how it performs. Okay, so I'm going to connect to sample again. Okay, but this is a new connection, and I want to reset monitor all. Okay, so I'll come back here and I'll say reset monitor all again. Okay, and I have to set this activate not logged initially attribute. Okay, so I'm going to set that, and after that I'm going to run this, right? So this query I'm running. Okay. Oh, activate not logged initially. This is the same query, so I'll not run this. I'll run this query. So I want some change, right? So okay, I'll copy this. What was the last query here? Yeah, I don't want to run the first query. I'll run the second query so that the data is different. Okay, so I'll copy this. I'll run this here. So this time it's not taking any transaction log files, so there won't be any IO on the transaction log side, but still you can see it should be really slow. So we'll look at the monitor, so you can see here. Okay, so So let it run. Okay, 14 seconds. So we got because of the caching effect. So let's now commit the transaction. Okay. Look at now. The query executed in 14 seconds. Okay. And I wanted to commit now. But look at what the commit is doing. Look at that. Buffer pool data writes. How many asynchronous writes are you seeing? There is all total writes. There is no asynchronous writes. Asynchronous writes is 0. Similarly for index also, once you will come, see this is still committing. So the query ran faster, but the commit is taking such a long time. Why the commit is taking such a long time? Because it is performing a lot of synchronous activity. See, the data is completely getting returned by the agent itself from the memory to the disk. There is no asynchronous page cleaning happening, which is really helping you in pushing the data to the disk. So all this parallel execution of the agent prefetching the data into the buffer pool, and page cleaner is cleaning up the pages. The CPU is capable of that, but the hard disk speed is limiting that. Okay, and you can see very clearly that, see, it's going to run for 5 minutes, I guess now. So you can see that, see, 20,665 data writes, but nothing is happening in a asynchronous manner. So the process, if any query execution, it is using the buffer pool, but if it is not going to utilize the asynchronous writes, it is bound to be slow. It is bound to be slow. This is such a if you understand the internal workings of the buffer pool and the page cleaning, and you should be able to understand that. Okay, this is what I was telling. Activate not logged initially is more of a space saving mechanism rather than performance enhancing mechanism. So that's what I want to convey. So you can see the query runs faster. Okay, so the update query ran fast, happy, but the commit, even if I can't even roll back, because if I say activate not logged initially, I cannot roll back. The only option for me to is commit, and if I perform commit, it is going to be extremely slow. Why? Because of the synchronous writes. See, now the index also has started, and buffer pool index writes is only happening. The asynchronous writes is 0. It's not even like some part of the things are asynchronous, maybe 50% synchronous. It's not even like that. It's completely like asynchronous. I mean, that is insane. That is very bad, actually. Okay, I think this 24,000 has stopped, which means the data portion is complete. Now the index portion is getting built, or getting returned. So you can see this stopped, and this number is increasing. And when you look at the buffer pool, I think it should reach about 50,000, I guess, maybe 23,000, 22,000, 23,000. So you can see the time here. See, 14 seconds it executed the query, but the commit is going to take a very, very, very long time, which completely defeats the purpose of the claim that the performance is going to be good. Performance is not good. Update query can run, but the commit, if it's going to take so much of time, there is no point. Whatever the performance gain I got it in update, I am losing it in commit, and I cannot really roll back also, because it will put the table itself in an inaccessible state. So if you are running a long update query or a long delete query like that, and you think that when you run activate not logged initially and you run the update query, it will run very fast, that's a wrong claim. That's why I said it's a general statement. It is not very specific. It is very highly dependent on the log IO disk speed and the data and index speed. See, if your data and index hard disk speed is good enough for taking this synchronous writes, okay, now let's think this way. Instead of synchronous writes, even if you do the direct writes itself, we could have done it somewhat, the IO will be lesser. If we would have gone for a direct writes, load utility is using direct writes. It bypasses the buffer pool and directly writes into the table container. That itself will be faster. Now you have to unnecessarily fetch the page into the buffer pool and write the page back to the disk, all in a synchronous manner without using page cleaners. That is so stupid, right? See, you don't see not a single asynchronous index writes is happening. Everything is synchronous. So it's going to take 5 minutes. Even though we did not deactivate the database, and the buffer pool was filled with so many data pages from the staff table, still the commit is extremely slow. This never happened when you were running the previous examples. See, the commit was always 0 seconds, commit is 0 seconds, commit is 0 seconds. The query only will run somewhat. The first time it ran 5 minutes because it was the first initialization of the buffer pool. After that it was running 31 seconds. After that it was taking 3 minutes. After that it was taking 31 seconds. So the caching effect, we are able to see something, right? And I did not deactivate the database, and you see that the update run 5 minutes and 40 seconds. And this 5 minutes and 40 seconds is pretty consistent. So if I go to I'll do this same test case again. So I'll come here. Oops, something I did. Okay. So I'll run the activate not logged initially once more, and I will run this query again. So I think this video is going to be too long. Okay. So this update might run faster. Maybe in another 15 seconds this guy might complete. Okay, so let's see that. Okay, see, 11 seconds the update got completed. Okay, but what is the point? I have to commit the transaction. So before committing the transaction, I'm going to hit reset monitor all. So you can see everything is 0 now. Okay, so I'm going to hit the commit. This time also it is going to take 5 minutes. If it is going to take 5 minutes, then there is no point. Then what I can say is, if you use activate not logged initially, consistently the activity will take 5 minutes instead of 3 minutes. Even if you use if you do not use the activate not logged initially and you log all the transactions and you provide additional space, but it will run in 3 minutes. Here it is running in 5 minutes, and this 5 minutes is a very consistent number. So you can run it. I'll run it only 2 times, but I have run it 3 times because just for the sake of the length of the video, I am not running it 3 times. But you can run the same test case 3 times as well. I'm sorry. So now the data is 10,438. 14,000. None of them is asynchronous. Everything is synchronous. This is a bad sign. This is a bad sign. This is a sign of poor query execution. It's going to take 5 minutes. I cannot. This is going to be a long video. I'm sorry for that, and I'm. So this is already we have spent 15-20 minutes, more than 15-20 minutes. So I'm just leaving this. All the examples and everything that I use obviously are available in DB2 LUW blogspot.com. So I used to put it there. So that point is always there. So you can go ahead and download the files there. Okay, in blogspot.com. DB2, I think it is db2luwacademy.blogspot.com. So you can check that. See, now the index writes have started. And nothing is synchronous. I mean, nothing is asynchronous. Everything is synchronous, which is a bad sign. Let's see how much time it takes. It should reach about 50,000, I guess. Now only we have reached. So this is 24,000. This will reach around 50,000. Well, let's see what's the previous number. Yeah, 46,000. This should reach around 46,000. So let's check that. We are reaching only 14,000. Wow, it should reach around. I'm sorry, but this is going to be a long video. 16,000, 18,000. This is where the disk speed comes into picture. See, what happens is when you run this commit, right, there is a lot of synchronous writes happening, and this synchronous writes, it's totally dependent on the disk IO. So the index disk IO and the data disk IO, if you have sufficient bandwidth, it will appear as though the commit is running very fast, but it is performing synchronous writes. It is not using the buffer pool in an efficient manner by performing asynchronous writes as the query is getting executed. This is the concern that I am raising. And I am also using a DEC edition. So I'm not sure whether it is a, if I look at the DB2 level, it is 11.5.6 DEC edition. So it's like a free edition. So maybe in enterprise, I don't know whether it behaves in a permanent community edition. So maybe in enterprise, whether it behaves differently, I don't know. That is a challenge for me because I always work only on my personal laptop, low power laptop. So it's going to happily take, we have to reach that, see, 0 asynchronous writes, 0 asynchronous index writes. Even the temporary data also, if you want, you can see, for example, I'll show you the temporary also. See, temporary. So if you look at temporary also, see, temporary logical reads, here is 0, here also it's 0, here also it's 0. So temporary, it's not using the temporary space much, so we'll not worry about it. But I'm just saying, even okay, 46,000 it has reached. I think it is going to get completed. Let's hopefully it should get completed. 47,000. 49,000. But look at this asynchronous, nothing. So totally it is writing in a synchronous manner. The data portion also synchronous, index portion also synchronous. Then what is the point actually? You don't need to put that in the buffer pool itself then. You could have performed direct IO itself. Correct? So see, 5 minutes 40 seconds, how consistent it is. And I'm telling you, I am not going to run this third time, but you can run it third time also. You will get consistent. The query will execute in 11 seconds, 12 seconds, but the commit is going to take 5 minutes and 40 seconds. It's only because of the varying data disk speeds. So I have set a speed limit such that, see, I have various disks, right? I have showed you IO stat -D-2. So if you look at my SDA, SDB, so SDC is the disk which has the index, SDD is the disk which has the data. It has only a capacity of 1024 KB per second, whereas SDB is my logging disk. It has there is no limitation, so as long as my hard disk is giving, it will use that. There is no bandwidth limitation on that. So it is kind of a mimicking a scenario where I use different kind of speeds with different disks with the different IO speeds. So that's the concept. Okay, so that's why I did that. Okay, so hopefully this information is useful to you. Subscribe to my channel, youtube.com/db2luw academy, and see you in the next video tutorial. Until then, bye bye.